box sits on the frictionless 40-degree ramp. The tension in the spring that holds the box in place is 5 newtons. Wants to know what's the mass of the box and what's the magnitude of the support force provided by the ramp. Okay, so again, I think I'm going to draw my free body diagram right on this. So there is going to be a weight force on the box from the earth. There's going to be a support force there's going to be a support force on the box from the ramp, and there's going to be a tension force on the box from the string. It's not changing its motion, so that means this must be equal to this. This must be equal to this. So let me go ahead and write my two equations. The normal on the box from the ramp must be equal to the y component of the weight. And the tension force on the box from the string must be equal to the x component of the weight. So the support force on the box from the ramp would be equal to the weight in the y direction. Hopefully, if you can see that this is 40 degrees, then this angle up here must be 50 degrees. And so when I make my triangle here, if that's 50 degrees, then this angle down here must be 40 degrees. And so therefore, if I want this side, because that's the one that's equal to the support force, that's going to be given by the cosine of 40. Unfortunately, at this point, I can't solve that equation because I have two unknowns. So let's go with the tension equation. I know the tension is 5 newtons. That's going to be equal to the x component of my weight, that side there. So that's going to be the weight on the box from the earth times the opposite side to the 40-degree angle. So that's sine of 40 degrees. So that means I can figure out the weight force. And that weight force is 7.78 newtons. And since it wants to know the mass then would be 0.778 kilograms. So there's my first answer. The next one wants to know what the support force is. Well, the weight we just found was 7.78 newtons. Now, if I just multiply that by cosine 40 degrees, that's going to give me my support force. And the support force ends up being 5.96 newtons.